Welcome to our session 6 in the Dryden Aqua, Aquaria and Zoo webinar series. Today we are sort of tying everything together from the previous webinars that we've been doing and talking about how Dryden Aqua's AFM filtration media can help solve many of your problems, or at least improve a lot of the system problems that might be out there. We will be running through this presentation in a little bit more detail about AFM and how it works. So yeah, stay tuned. As always, we're starting off with 3 different steps. We should actually do the quick introductions again. I keep forgetting. It's Mike Domain, been in the aquarium industry for many years. Lots of different experience on animal husbandry side and also life support systems.
Mike Causer, been in the aquarium business for many more years than Mike, both in as curatorial experience as well as big aquarium design.
Yeah. And last but not least, Jacob Serber. I have been in the aquaculture side, although not as many years, but I still do have some experience with recirculating system and especially what nutrients do, either if they get into the system from the outside or if they are in the system accumulating.
Great. So we're going to step through this in a little bit more detail about Dryden Aqua, who we are, how we make AFM, why it performs so well, and the difference that it can make in your system, whether it's a fish system or a mammal system. So let's start off and go into the next slide. As always, you are welcome to visit our website, where we have a lot of detail on our website in terms of user manuals, in terms of operational performance, in terms of case studies, lots of information on the downloads page. So please go and visit our downloads page. If you have any questions or just want to see the detail and be able to read through it yourself slowly. Like we do in every webinar, we just do a quick review, 3 simple steps of the previous webinars. I think we are tying it all together now. So we're talking about the reduction of biofouling, which we've been going through in webinars 4 and 5, and then how that interacts with the reduction of ozone residuals and also chlorine residuals when it comes to mammal systems. So ozone on the fish side and also on mammal side sometimes, but on the mammal side mostly about chlorine residuals and how we can help reduce all of those problems.
Absolutely.
I'll leave this one up to you, Mike, seeing as you've been with Dryden for the longest amongst all of us.
And Dryden Aqua was founded by Dr. Howard Dryden. He is also a marine biologist, so we're very much a marine biological company, and he was interested in how biology interferes with filtration in filtration systems. He was particularly concerned about dolphins living in chlorinated systems and the risk of lung infections that they might suffer as a result of poor management of those chlorinated systems. And his mission was to develop a technology that would prevent biofouling of filters, because he recognized that there was a lot of biology in the filters themselves, and he wanted to better control that in order that he could improve particulate filtration.
So he actually tested many different medias in the process of developing AFM. Is that correct, Mike?
Absolutely. Yeah. And he did his PhD in zeolites, thinking that zeolites were going to be the answer to providing better filtration for aquaculture in particular. And he discovered many of the properties of zeolites that he really wanted, but the disadvantages of zeolites were stronger than the advantages that they brought. And then he discovered that he could impart some of those properties into glass by treating it in particular ways.
And that's how AFM was developed, and what we're going to go through in a little bit more detail in this presentation. So what is AFM? It's recycled glass, but I should let you, as a newcomer, talk about this, Jacob. I'll throw you into that.
Well, always being thrown in at the deep end, exactly. Well, what is AFM? AFM is produced actually behind this backdrop in the Swiss facility, which we're going to see right now. AFM is a recycled glass filter media. We do crush about 150 tons of glass here in Switzerland per year to produce something which, in this particle size, is similar to sand. However, has a vastly improved surface area, also as it is bioresistant, which we're going to see as well later on how this works. There is no biofouling in the filter. So we do not have many of the problems that do arise from the biofouling that occurs in classical sand filters.
Yeah, and just a little bit of a correction, we create a little bit more than 150 tons. We're actually capable of making 30,000 tons a year.
Sorry, that was daily.
That was a little slip, but not a problem at all. We have clients that actually buy 150 tons at a time from us, so that's probably where that came in. But yes, a total of 30,000 tons this factory can produce, and also the factory in Scotland is around about the same capacity as well. Both being able to produce all of our AFMs, the AFM Standard and the AFM NG in all the different grades. So, but we'll go into those details now. As you can see here, we've actually got a very nice video that we've made on the production. So instead of you walking you through this facility, which of course we're always happy to do if you're able to come and visit us, we can walk you through either of our facilities, but this is a quick video to show you how we do it. And let's start that video. And this video is also available on our YouTube channel, so if you ever would like to watch it again, please feel free to do that. You can see on the side here as well, fully container glass only, with the metal oxides in it that we need for the activation process. So because clear glass doesn't have the metal oxides in that is required for activation processes, then we re-engineer that glass into certain particle sizes and, very importantly, particle shapes. And then after that, it goes through the activation process, which helps AFM achieve its unbelievable filtration performance. Mike?
Yeah, and the specificity of AFM is that it has very particular surface properties. It is an activated glass media, and that activation increases the surface area. Green glass, green or brown glass, has metal oxides in it, which are necessary in order to allow us to give it the properties that we need. So that provides the foundation for our activation process. And green glass has a surface charge, and the surface area is very, very important. So we increase the surface area in order to increase the charge density on the surface.
So unlike other glass, green and brown glasses that might also have a charge on it, we increase that surface area. Is that how we increase the performance, Mike?
Absolutely, absolutely. Yeah. And that increases the charge density. So very, very important. And the activated surface of AFM has catalytic properties. It allows us to dissociate water molecules into free radicals on the surface. So right on the very surface of AFM, it performs like ozone. It's actually, for a bacteria, it's like a hot plate on a cooker.
Yeah, so the bacteria can't
they
settle
literally
on it.
cannot settle on it. If you try and put your finger on a hot plate, it's too hot.
Yeah.
You can't stop. And if a bacteria can't settle on the surface of AFM, it can't then protect itself with a biofilm, and that's what means that we have no biofouling in an AFM media.
What might be important to add here is that these amounts are generated are still fairly low, so there's no fear for you that you will have free radicals going through your system and wreaking havoc on your on whatever species you're keeping in that system.
Yeah, that's correct.
They do keep the bacteria from forming a biofilm on the surface of AFM.
Yeah, it's really just a surface area on each glass grain where this is created, and nothing is released into the ongoing water as the water is flowing through. So you won't find free radicals flowing through your system. That's correct. Nice.
We've been producing AFM now for more than 20 years. And 20 years ago, all we produced was AFM standard, which is activated to enhance its negative surface charge. And that negative surface charge allowed us enhanced filtration by adsorption of positively charged contaminants. And in chlorinated systems, for instance, we use coagulants and flocculants. And the carrier for those is aluminium, which has a positive charge. So it is adsorbed onto the surface of standard AFM. And then we were looking at some contaminants that we wanted to have enhanced removal properties. And we developed AFM NG, which actually filters to 1 micron. NG is activated in a different way in order to have hydrophobic surface properties, and that allows us enhanced removal, enhanced filtration of hydrophobic contaminants, particularly of oils, fats, and organics, which are obviously the key contaminants in any aquarium system.
So that's correct. So there you can see this is now our priority product, the AFM NG that we use in all organic removal applications. Like Mike was saying, it's gone up to about 90% of the product that we sell, because many applications are for organic removal. It's really only in applications where we have metals removal requirements, and we don't pull metals out of solutions, so please don't misunderstand that. But once your metal has been brought out of solution by and oxidation process, then the AFM standard is very good at removing those metals. whereas the NG is very good at removing all of the organics, microplastics, lipids, fats, and all of that. So we've, historically, sometimes we've been to shows and we've been told we're selling snake oil in a way, and it's actually really great to be able to have these two products where we can physically show the difference on a stand. And here's the video of the difference of those products. The AFM standard is up at the top, and you can see how the negative properties of that pulls the water onto the media, whereas the bottom sample is our AFM NG, and it really repels the water off it. Historically, that was problematic for Howard when he was initially creating the AFM NG, because he had to figure out just how much hydrophobicity to impart onto the AFM so that it could still act as a filtration media and not a water blocker. Initially, it was so hydrophobic that it was actually holding the water above the media and wouldn't let it through. So that took a few years to get right, and now we're operating, like Mike was saying, down to 4 microns removal at 1 micron particles size removal at 95% efficiencies.
And the grain size is exactly the same.
Exactly the same.
Yet the two products perform very differently.
Yep. So it's pretty impressive what Howard and his son Matthew have managed to achieve over time. You want to talk to this, Jacob?
Well, there is obviously differences in how to measure filtration. And we can't talk about absolute filtration, however, in practice, at some point we have to say, okay, we're filtering out 95% of the particles that are coming in, because absolute filtration is just going to not be practical in usage. So we took this 95% and we said, okay, at what grain size can we remove 95% of any kind of particle size? And as you can see here, the little green line you see on the top left and the little red line, this is AFM grade 0, so the very, very fine grade AFM, which performs even slightly better than AFM NG, so at filtration. However, you should be aware that this will cause back pressure as we have a very fine filter media.
Yeah, and it can only handle flow rates of less than 10 meters per hour, filtration velocities, because it is so fine. So it's really used in very specialized filtration requirements. We don't sell it that often.
Exactly. So you see next on this list is just AFM grade 1, the normal AFM S, AFM standard, which still at 4 micron filters out 95% of particles. Then what is next on this list is actually just classical sand, a sand filter, how these media filter have been used for a really long time. There are two things that have to be noted here. Sand is not equal sand. So sand in Switzerland and sand from the Netherlands and sand from the UK do have
or the Middle East or America, whatever. They all have very different performances. Yeah.
Of course. Sorry, it was a bit Eurocentric in here. They do perform very, very differently, as they have different particle size distribution, even within that 0.5 to 1 millimeter grain size, and also they're shaped differently.
Yeah. So sand performance varies according to which hole it was dug from. Yeah. And AFM is an engineered product. So it is consistent and quality controlled to always give the performance as shown on these graphs.
The second thing, which is really important about sand, is we're talking about fresh sand here. Yeah. And biofouling is one of the major advantages we do have. So, after 2 months, 3 months, 1 year, this sand is going to perform massively worse than what we see on this measurement.
Yeah, and all of the other ones below are different kinds of glass medias. And again, just showing that a glass media is not a glass media, is not a glass media. And on the majority of time, your sand medias, and this is all brand new media, whether it's glass or sand, brand new media. So your sand medias might outperform the standard glass medias on the market. The bottom line is the very rounded glass beads. That will always have the worst performance. If you go back to our reference of session number 2, where we talk a little bit about how filtration works, that explains that poor performance there very nicely.
Our factories are the only glass media manufacturing factories that are dedicated only to producing glass media. And therefore we optimize the shape and size and performance of AFM to give better filtration. Most other manufacturers are manufacturing for the remelt industry, for shot blasting, sand blasting, and they've discovered that if they put glass media, filtration media on a bag, they can get more money for it. But it doesn't mean that they understand what is required in order to give the performance that you guys need.
If we could maybe just go back to the last slide really quick. There's one really important point which we have to add here. These may just look like, obviously we're all working for the same company and we're bashing our competitors. These are not our measurements. These were done by an independent tester. By what was it?
IFTS.
By IFTS. So this is not our data bashing our competitors. This is independent testing getting, very similar results to what we are getting when we do the same measurements.
That's correct. And it's the exact same graph we had in our session number 2 presentation, which does have the IFTS logo. It was my mistake for not putting it on this one, so I apologize for that. But yes, Jacob is very correct. It's not our testing here. However, if we then look at the following on tests, because we have our own test lab at our in our Scottish factory, we do a lot of testing of our own media to make sure that our performance stays consistent into the future. But in that process, customers sometimes ask us to check, to test other medias in the same way we test AFM. And this is some results that you can see here, which is a backwash efficiency test at 40 meters per hour. We like to vary the different flow rates, but you can have very different results from them. This testing was done on sand, so the green line is AFM NG. The Swiss sand, or let's rather be correct, that's a German sand from a German manufacturer. The UK sand is the yellow line, and you can see in the backwash performance that the release of the particles is far worse in the 2 different sand medias than with the AFM. And that speaks back to our session 2. We explained why that backwash is so important, and this shows why AFM does so much better in the long run. Not only that, if we look at the time it takes to backwash these different materials, it's a very big gap in that process. But more importantly and consistently, what we do is we follow that up with a second test. So this was on other glass medias being tested in other glass manufacturers. We did a backwash test, the same test as with the sand. We did that with the other glass medias. You can see that the glass medias perform better initially than the sand on release of the particles at 30 meters per hour. You can see the AFM drops off down to 0 very, very quickly. But then what we did was we bumped up the backwash velocity up to 60 meters per hour, and all of the other glass medias had a secondary spike of dirt out of that media. And that is because of the shape, the particle sizes, all of that of those medias that don't allow for good bed expansion, and also fluidization. So that media tends to hold onto dirt rather than releasing it during the backwash process.
So the performance in backwash is just as important as the performance in filtration.
It's actually more important,
yes,
I think,
absolutely,
Mike. We're starting to learn that more and more.
If there is material left in your filter after backwash, it will exert an oxidation demand,
Yeah.
and it will destabilize your system.
And it accumulates over time. So if you're not refreshing your filter as new every time, your organic load just climbs over time. And quite often that's why sand needs to be replaced, is because of that slow climb in organic load. Not only that, but also in a well-designed filter with sand, which can filter very well for many years, but the sand does become rounded over time, and then you get that filtration performance such as you saw with the rounded beads in the previous graphs.
Yeah. And I do think one of the really important points to add here is, and this comes from Jochen, our water treatment guy, is like filtering out dirt, no matter what dirt that is, that's not the difficult part.
Yeah.
But getting the dirt back out of the filter, this is what is hard. And this should be one of the major advantages we have with a media filter, with a sand filter, that we can backwash it. Because something like a sock filter or the other long ones, which I forgot the English name for.
Filter.
Yeah.
Or the cartridge filter,
Yeah.
let's be honest, most of them just get tossed out. We can backwash a media filter. And if the backwashing is not working properly, well then why do we have a media filter?
And just to speak again, so this is a review of the same slide from session 2. Backwashing at 30 meters per hour, you can see that there was still residual left in the filter. After the backwash, there was a lot of organics just moving around on top of the bed because they were not achieving the velocities needed to lift those heavier particulates out of the filter. Whereas if you bump that up to 40 meters, which is our minimum recommendation of backwash velocities, you can see that the filter is totally clean after that process. It's very nice working in these different industries because we get to see these gravity filters operating and can assess this and show you quite clearly on videos and photos of what we are trying to describe from a velocity point of view.
We also get challenged by different contaminants and specific requests from customers who are looking to remove a particular contaminant from the water.
Yeah.
And we like those challenges.
Yeah, we like those challenges because with our lab we are actually able to test and give the client a performance of how our media will perform with that particular contamination.
Sure.
Yeah.
Or what additional techniques are necessary to remove it.
Yes, during the backwash process. Very much like oils, we are being used quite heavily in the oil removal process as well, and that obviously requires very specialized backwash techniques,
Yep.
either solvent techniques or hot water or so.
Or iron and manganese and
Yep.
different metal contaminants.
Yep, exactly. Yeah. So that's a quick, broad spectrum what AFM does and why it is so much better than the other medias, but it very much speaks to all of the previous presentations or webinar series. So please go and have a look at those if you have not seen that yet, because moving forward we're going to talk a little bit about the benefits of that in fish systems and mammal systems or chlorinated systems.
Okay, so what are the benefits of AFM in fish systems? Primarily in Aquaria, you want the crystal clear water, and if you filter to 1 micron, then your water is very much clearer, obviously, than if you can only filter to 20. There is a potential for reduction in the mechanically filtered turnover. So if we're removing finer particles more easily, then maybe you don't need to turn it through the filter as often. And you can actually look at fine-tuning your filtration turnover a little bit. There will be a massively reduced load on biofilters and protein skimmers. And finally, better biosecurity. And we can filter out and remove parasites, bacteria, and in particular, cryptocarrion. Every single stage in the life cycle of cryptocarrion we can filter out. So all of those motile stages we can remove, and also the encysted stages we can remove, and they will be flushed away in backwash. So we can reduce the load on your system. AFM is bioresistant, so dissociation of particulate filtration from biofiltration is very important. It allows us to house the biofiltration in the right the right environment in a purpose-built biofilter. And because the media is bioresistant, there is no risk of Vibrio proliferation in the filter or other bacteria, other parasites, pathogens that can live in any sand filter. Ultimately, you have much more stable filtration, better removal of reducing agents, and a higher ORP in your system even before you turn the ozone on.
More stable ORP. So the standard ORP, we're not increasing ORP with the AFM media at all, but
nope.
we are facilitating that your ORP is not being reduced by the organic content within the media. So we are not claiming to increase ORP at all with our media.
No. We just remove more of the reducing agents.
That's right.
And therefore we tip the balance in favor of the natural oxidizing agents in the water.
Yeah.
Reduce running costs, dramatic reductions in running costs because the pressure drop across AFM is less than sand. The two graphs at the bottom are very interesting. Those are actually from a water treatment plant.
Yep.
And the graph on the left shows the filters operating with sand, and after each backwash the system takes a long time before it's filtering properly, and hence the reason why you see these turbidity peaks. That water cannot actually be used until the system stabilizes, and therefore they waste a lot of water. With AFM, you can see that the graph on the right, you can see little blips after each backwash, but always the water quality is acceptable, within acceptable limits for drinking water, even immediately after a backwash.
Yeah, and also that speaks a lot, the graph on the left speaks a lot to the inconsistent filtration, because this is not only after backwash, but this is also the inconsistent filtration that you are getting through a sand media, because very much of the channeling events or what we call breakthrough events, as well as bacterial cell biomass is being released into the downstream system through your normal filtration processes. So that never occurs with the AFM.
Yeah. And we would expect the performance that you see in the right-hand graph to last for 50, 20 years.
Yep.
Without any media replacement. As long as our backwash protocols are respected,
yep.
As long as our installation protocols are respected, then you can expect that performance for many, many years.
Without ever needing to change your media. So if we look at, you want to speak to this one, Jacob?
Well, yes. So what we can see here, can you please click for the next one? So we do have the silica sand, which does filter down to 20 micron. Obviously, this is a very, very fine filtration, which is great. But we can go down much further, and this is really interesting. If we see what starts getting filtered out, if we filter down to 1 micron or even down to 0.1 micron if you use the entire thing with flocculation, because you see there, if we go down to 0.1 micron, there's actually a lot of bacteria, and especially a lot of parasites, well, I would say almost all parasites that are going to be filtered out. So, being the aquaculture guy here again, in any kind of hatchery systems, parasites, or almost all kinds of hatchery systems, parasites are always a big problem. So if we can filter out parasites in every cycle, we can massively improve biosecurity again.
Yeah, and if we talk directly from perspective of reverse osmosis systems, which we also do a lot of work in, because we are filtering down in the microfiltration levels, we are dramatically improving the performance of those systems too, and lessening the requirement for ultrafiltration membranes needing to be replaced, or microfiltration membranes needing to be replaced. So again, experience from other industries has really helped us in our overall specifications. If we then jump onto the mammals and birds side, where it's very much the same as what we're doing on the aquarium side, where the big increase in removal of the organic load means a reduction on the requirement for chemical additives, either chlorine or ozone, and by reducing those the need for those chemicals and also removing the biological fouling, we dramatically reduce or eliminate, but I would rather say reduce the prevalence of trichloramines, which are then affecting the animals' breathing or eye, mucuses on their eyes or the mucus within their lungs, creating possible health problems down the line. Also, even in those systems, we're talking about the more stable filtration and all of the reduction of the running costs over a long period of time, actually into the future. So your return on investment is very, very fast in many of these systems because we're reducing the chemical demand and your water consumption goes down, but refer to those seminars to see all of that detail as well. So seminar 2, 3, 4, 5 are all very important precursors to this presentation. Feel free to jump back to those and have a look. Anything else you wanted to add there, Mike? Did I skip on anything?
I think no. We address the problems that are specific to animal health.
Exactly.
And classical problems of trichloramines, disinfection byproducts.
Yep.
We treat all of those very much better.
Yeah.
And we provide much more stable, healthy conditions for the animals.
Yeah. And all of that while also saving money in the long run too. So, we are always available for questions. If you want to assess whether we can help you or not, please contact us. You can see on the slide currently, all of our email addresses are there. We're always available. Pop us an email. We like to learn. We don't know everything, and nobody knows everything, and therefore we're always happy to learn with you through your process. We have learned quite a bit in our past as well, so there is a lot of information that we can share with you in this process, but we do understand that we're not the be all and end all of life support systems. We know that very well, but we do play a very big part in making life support systems more efficient for your facilities, which leads to better health for your animals.
We're stronger together.
Yep.
And we work much better with you as a partner, with feedback in both directions.
Yep.
So that we can continue to help you to improve the performance of your systems.
And about working together, I would add, as the aquaculture guy, a little call for action in here. We would be very interested in doing more experiments with side loop filtration. Obviously, cycling an entire RAS through a media filter, even if it's a great media in there, that's going to be quite hard. But we would be really interested in doing additional experiments on running a side loop and therefore decrease the organic load on the filter so the filter can do what it's supposed to do instead of MBBR getting out all the particles.
Yeah, so that's very particular to RAS systems, aquaculture systems that call out. And yeah, so we're very interested in doing a lot of work on that. We've got 2 projects on that side happening at the moment, but the more we can do, the more information we can generate, and the more we can help facilities. Again, the overall picture is prevention is better than cure. Okay, we save you water, we save you on the residuals of ozone, chlorine that affect your animals in your system, and then there's a benefit of electrical energy efficiency as well at the end of the day. So we are there to help on numerous sides, and we would be happy to do so. I'd like to thank you very much for joining us for these 6 sessions that we've had, and please we will be increasing our content on our YouTube channel. As I've said before, here's all of our social medias that you can just click onto. LinkedIn, I'm pretty active on LinkedIn. Jacob will be quite active on LinkedIn as well. And then our YouTube channels, where we'll be increasing our content and putting more videos on throughout the year and in years to come. So please walk this road with us in learning and experience, and we're happy to help as we go along that process. Have I said enough?
Well, except no. Thank you all for bearing with us throughout this long series of webinars. We hope it's been interesting to you. We hope you've learned a little bit, and we hope to be able to help you to further improve the results in your own filtration systems.
So thank you very much, and we look forward to our online chats, whether it is via email or at shows like the Also show or any of the others, the European shows, the Asian shows. We are always available and happy to chat to you.
Thank you very much, and see you next time.